All right, well, we're privileged to be a part of the midterm presentations today, and thank you for this opportunity. I'm glad we were able to pull it together despite all the challenges that we've faced to get it done. But it's good to be with you today. We're scattered around our city, as you likely are as well. And of course, our researchers are joining us from Atlanta, so I'll jump right into the presentation here. Uh, Got next. All right, since this is a part of the our a deliverable, and we wanted to make sure that we just went back and talked about the things that are a part of our project. We are One of the phases is that we want to Wi-Fi connect our uptown area. So connectivity and getting that infrastructure in place is something that's important and a part of this conversation. We want to look at the challenges that we have with economic development and see if this can also be used to improve that. And we've worked with some of the businesses downtown to see how we can use this data and present it in a way that is useful to them. We want to increase the public safety aspect of this. We don't feel that we have an issue, but we always feel like that if we can improve that, then that's just a positive thing. And then, of course, to expand the partnerships between public and private entities. If you were here as a part of our event, you saw that we did have several business people present, and then some even stopped by on the street to chat with us for a moment. And we want to make sure that we're including all aspects of that. Columbus State University has a presence downtown, and we feel like they can benefit greatly from the Wi-Fi that we want to put in there. So it's a great partnership to see if we can't get everything connected downtown and improve the ambiance and the financial goals that our business owners have there. Scott, advance. So we've broken this into three phases, and phase one is the area of Broadway between 10th Street and 11th Street, and we actually have installed two of the sensors there, and they are collecting data, and we are trying to figure out the best way that we can capture that data and see what's going to be the most useful for us. But those are installed, and we'll go ahead and proceed to the next. We have been able to join with the Columbus Police Department. Of course, we are the Columbus Consolidated Government, so we have been able to tap into the video feeds that they have, and we are using that, and we have sent some of that to our Georgia Tech professors, and they'll talk about that and how they're able to use that in just a moment. I'm going to turn it over to Andrew Lesh, and he's going to talk about what we are doing with some of our data.
So we just wanted to go ahead and get a look and feel for some of the data. So we started making a front end for the API, just so we could quickly refer to it and look at it. So on this page, you can see where it says click download tarball. You can actually download all the data that you'll see for each of these projects. It lists the sensors for you so you can see them all in one place. This is just mainly a mock-up for something that will be like a sister site to this that'll actually hold all of our regularly captured data as time goes on and we've captured more and more. But this gives us a pretty good way to just, as we're talking to stakeholders right now, show them kind of what we're dealing with, what kind of stuff we're able to gather. And this is just me walking through some of the features we have on it right now. So currently it starts with 500 entries and you can load in more. It has a charting capability, and something that we'd like to do is get some regression libraries in here so we can add trend lines to that, and we'll actually be able to kind of show over extended periods of time. Like this is going to show you about 24 hours, I believe. you would actually be able to see kind of how the temperature in this case changed. And this is all responsive, so you could actually have multiple of these going and uh, be able to interact with it in various ways. Like I said, this is pretty early on, so we will be adding more to this. And I'm going to give it to Scott, and he's going to talk about some of the data collection he had to do for modeling the city.
Thanks, Andrew. So one of the main components of this project was and still is developing a digital twin. It's been pretty much a very largely GIS-centric data development process. With this, we've incorporated a lot of existing data that we maintain here at the city level, as well as a lot of new data. A good example of some of the existing data that we maintain here at the city would be building footprints. Obviously, we're maintaining that data at a citywide level. However, for this project, we needed to refine it a little bit further to be used in a 3D model. And a good example of new data would be tree points. That's not really something that the city maintains. So for this project, we actually had to create a brand new data set of tree points in the uptown area. And we're very fortunate to have a high school intern, Brandon. He's from a local high school at the Muskogee County School District here, and he was able to assist us with adding the tree points for our digital twin model. And there's also adding characteristics like things like height, and we can do a lot of that through analysis. Some of it's manual and some of it's automated. On the right, you can see these are some of the core data sets that we use for development of the digital twin. You have things like ground level terrain, roof tree level terrain, the tree points, and as well as the building footprints. So this next slide is a video kind of showing how we did some of the analysis with regard to, for instance, for building heights. This is what we're calculating right now. So this is kind of running through the steps we use in the analysis. So this one particular tool we're using, we're generating random points on all of our building footprints. Tool is processing right now, and you can see the cluster of points that generated in the window. So then we have those points, we can actually go in and take our digital elevation terrain model, and we can say, hey, we can affix height values to that. So once we've created that, we can actually go in and we can generate a table. So we have all those points. There's hundreds of points per building, and then we can say, hey, we can compress those points and figure out what's the average height for each one of them. And then that generates an output table. Once we have that information, we can actually go in and I'm doing a little bit of field cleanup right here. We can take our building footprints, which previously did not have any height information. You can see a field for height above sea level, and we can take that table and we can actually affix that information to it. We can join it, and this is what we're doing right now. You can see there's a field for mean Z, and we can actually use that to calculate height above sea level. And really, this is just kind of the tip of the iceberg when it comes to analysis, some of the processes we were doing. I mean, obviously, this is building footprints, but you want to get, and we were focused on height above sea level, but there's also ground height, what's the difference, how tall is that actual building, and then you get into trees too, you have a height of a tree, and so on and so forth. But we just kind of wanted to give a sample of what we were doing analysis-wise. So how did we get our data from 2D to 3D? As I mentioned before, we created and edited our data in ArcGIS Pro, which is a GIS software application. From there, we were able to import that 2D data we refined, as well as the terrain data, into a product called City Engine, which is also offered by Esri. It's not necessarily a GIS product, but it has some quasi-GIS capabilities. But this is kind of where the magic happened, and we were able to convert that data, that 2D data, into 3D. From there, we were able to export that data into FBX files, and the FBX files are key for us to import it into Unity. And Unity is the application that Dr. Taylor and Dr. Mohammadi were able to use to create the digital twin. So this particular slide right here is kind of showing the difference between the 2D and 3D data. Obviously, right now we're looking at the 2D data, but by clicking that button, you can see with the appropriate attribution and appropriate refinement of data, you can take 2D data and create 3D data. I don't want to say pretty easily, but I mean, it kind of looks that way based on this little video. So there's a lot we actually want to still do with our 3D data development. We have a lot of future plans. Obviously, we'll want to refine some existing data. A great example would be the church you see on the right-hand side. Based on the way we did our analysis, all of our buildings have a very blocky look, but in reality, that's not the truth of, what's going on in the real world. Um, the buildings have sloped roofs, churches have steeples, so on and so forth. The same goes with the trees. We were able to do an analysis of height values, but we also want to incorporate crown width. So in other words, if you're looking down, like in Google Map or Google Earth, and looking down at a tree, how wide a tree is. And then maybe classifying it by whether it's a coniferous or a deciduous tree. And then there's also adding new features as well. We could probably incorporate road width polygons. And then all those street furniture elements that we were collecting last fall. And then finally, but definitely not least, we would like to incorporate the data from the AOT nodes to the digital twin, which Dr. Taylor and Dr. Mohammadi are going to explain in the next few slides.
Hi, this is Nita. On behalf of the research team and Dr. Taylor, I will just go ahead and describe some of the research progress that we have made. So thankfully from the CCG team and their data that they've generated in terms of the geometry of the city and the data about the buildings and trees and streets furniture, we were able to create this digital twin in virtual reality version of the Broadway, the phase 1 of the project, and sort of established a connection between the data flow from the AOT sensors that we have installed in the 10th Street and the 11th Street. And so the connection now exists, and we can sort of go in there and, for instance, in this 11th Street intersection, we have the data that comes from the AOT, mainly in terms of health indicators and environmental indicators such as air quality, sound intensity, weather conditions like humidity, temperature, cloud cover, sound intensity. And then we are able to monitor the data in a time series heads-up display and go back and forth in time using the scroll bar and see the changes, see the spikes and anomalies, and evaluate correlations. There's a dynamic radar chart on the second panel from the left that you can see. We display comparisons of multivariate air quality observations in this case across time, and then we can overlay the data and monitor the changes. So this is one piece of the data integration to the digital twin, but we still have another piece that comes from both the camera and Wi-Fi and another element of the AOT to sort of generate the street condition data and traffic flow in terms of detecting and tracking pedestrian vehicles, lights, and sort of all the conditions in the street. And here it is a little demo of the tracking analysis that we are doing, and now we are trying to integrate these two into the digital twin. And the objective for our first phase is discovering the relationship between the mobility in that intersection and the environmental impact data that we get from the AOT sensors. And in the further phases, phase 2 and phase 3, we will work on providing more decision-making insights in terms of safety and collision that happens in that intersection. There has been a recent case where a disabled person was hit, and we want to evaluate those conditions in the street and see what are potentially the root causes of safety concerns in those areas, and then finally evaluate what are the potential impacts of mobility on business activities and specific days of the week that people attend events, and the days in the summer that people gather along the Chattahoochee River for further events. And so right now, all the data that comes through these sensors are semantically, spatially, and temporally stamped, and they're associated with a location and time. And that enables us to track any event or any changes that happens throughout the time, and go back to the historic events and evaluate them. So our plan moving forward is just to combine these data and improve our digital twin so that it can be made available to both the governments and hopefully the community.
So you can see a huge amount of work has gone in already into just phase one, and it's so amazing what Georgia Tech is able to do with just raw numbers and turn that into something that spatially that we can take a look at and begin to start using and comprehending. But we do have a phase two, which involves moving west towards the river, and that will incorporate a couple more blocks. And then our phase three on the next slide actually shows how we would plan to move west and then move north to finish up the entire Uptown project. The next slide. So our next steps really are to just continue developing the digital twin model that we've seen displayed today. We are going to continue conversation with Georgia Power about Wi-Fi APs on poles and get those installed. We have had good conversations with them. Part of the COVID-19 issue that we've had is that we have had to delay our meeting with Georgia Power. They want to come down and walk the area with us and see exactly what it is we're talking about. But the responses that we've gotten from them so far have been very positive, and we're looking forward to being able to work with them and finish out the step of getting the Wi-Fi APs installed in the Uptown area. And then finally, to continue with the analysis of data from the AOT devices, correlate that with data from other sources. We have access to financial data. We have access, as you've seen, to visual data through the camera system. Whatever we can do to pull it all together into one place and be able to just have a cohesive demonstration of what this is to be a smart city in Columbus, Georgia. So just briefly, another issue that we've had with as far as COVID-19 goes is that we have had a couple of issues with the sensors. They have been generally reliable, but every now and then they seem to, one in particular seems to have a hiccup and stops responding in a way that we would like to see it, and we aren't able to address that as quickly as we would be normally. So those are really two things, one our delayed meeting and the other responding to issues that we've had with the COVID-19 issue. However, I understand that some of the other cities, if you're working with school systems and other places that are closed at the time being, you've experienced those challenges even in a worse way. So we feel like we're mostly unaffected by it, but it has created some issues with us moving forward. And really, that concludes the presentation from Columbus.